In this video, we're gonna focus on Jamb 2026 possible questions. Okay, we are given a question here, class. They said a planet has mass n1 and is at a distance r1 from the sun. A second planet has mass m2 equal to 10 n1 and is at a distance of r2 equal to 2r1 from the sun. Determine the ratio of the gravitational forces experienced by the planet. So these are the options here. Okay, for us to solve this question here, we have to know what is gravitational field. Please take note. We said that gravitational field is a region where force of gravity is experienced or felt. And whenever you have solution force, whenever you have two masses and you are asked to find the force between two masses, we use Newton's law of universal gravity. Please take notes. Whenever you are given two masses and you are asked to find the force between the two masses, we use Newton's law of universal gravitation. Please take notes. So let's know what Newton's law of universal gravitation states. Please write. Newton's law of universal gravitation states that any two bodies of matter attract one another. Any two bodies of matter attract one another with a force which is proportional to the product of their masses n1, m2, and inversely proportional to the square of their distance. Whenever you are asked to find the force between two masses n1, m2, it might not be n1, m2 depending on what is given to you there. Please take note. To calculate for that force, we use Newton's universal law of gravitation. Please take note. So writing this mathematically here, writing the mathematical statement here, it means that F, that is force of gravity, is directly proportional to the product of the two masses n1, m2, and inversely proportional to the square of the distance. So we are using arrow to represent distance here, okay? You can also use D to represent distance. Please take note. So class, when you to remove the sign of proportionality from any equation expression, we introduce two conditions. The first one is to introduce equal to. The second is to introduce a constant. Please take note. So class, for us to use this particular formula here, I will have this to be F is equal to class, since we introduce this equal to here, we are going to introduce a constant. Though the constant can be, but in Newton's law of gravity, we don't use K to represent the constants. Please take note. We use the constant for Newton's universal law of gravity, which is G. And this is going to be G m1 m2 over r squared. From experiment, this G has a numerical value which is 6.70 times 10 raised to the power of minus 11 Newton meter square per kg square. Please take note. So class, let's solve this question here given to us. Class, let's solve this question given to us here. For us to solve the question here, we have to understand, we have to know what we are asked to calculate. Please take note. We are asked to determine the ratio of the gravitational forces, that is the two forces, F1 and F2. When they say ratio, if I have something like this, that is S ratio Y is the same as S over Y. Please remember. So that means we are asked to find the ratio of the two forces, which is said to be F1 ratio F2. So let's know what F1 is, and let's know what F1 is, and also know what F2 is, okay? Now from the question, let's know what F1 is, please. Let's say a planet, that is the first planet, planet 1, has, let's write it clearly, planet 1. This is my planet 1. I will call this planet 1. Okay. They said planet 1, which is having M1. Please take note. And is at a distance. Okay. The distance is arrow 1 from the sun. So let's have this as sun. Please take note. From the sun, from this distance to this sun here, it says arrow 1. Please take note. All right. That means this is the mass. The mass here will be mass of the sun. Please take note. So to calculate the force between this guy and this guy here, I will use Newton's law of universal gravitation. Please take note. But to calculate force between two masses, M1 and this, we use Newton's law of universal gravitation. Please take note. So our F1 here will be equal to class G M1. M2 is mass of the sun. Please take note. That's M sun over the distance is arrow 1 and the square. Please take note. We have this as the first statement. That's the first equation. Okay. Now let's interpret the second one here. Planet 2. The second one is planet 2. I have this to be planet 2. Please take note. So planet 2 is having mass M1, mass M2, sorry. Planet 2 is having mass M2, and that M2 is 10 M1. Please take note. Okay. What happened to planet M2? They said, and is at a distance of arrow 2 equal to 2 arrow 1 from the sun. So I have the sun like this. This is my sun here. Listen. Okay. This mass of the sun. So the distance from here to here is arrow 2, which is equal to class 2 arrow 1. Okay. So let's find the force between the two masses, that is M2 and mass of the sun. When you do that, our F2 will be equal to class G M2, that is this first mass here. Okay. The second mass will be this, that is M sun over the distance is 2 arrow 1 or square. Please take note. So when you simplify this, I will have this to be class this will be equal to class G M2 M sun over this square here is affecting both 2 and arrow 1. So my result here will be class 4 arrow 1 square. So class, this is my mass F2. Okay, but we're not asked to find F1 and F2. We're asked to find the ratio of both. So to find the ratio of both here, that means this is what we are asked to find. We're asked to find the ratio of both. So let's replace this here. The ratio of both, that is F1 ratio F2, will be equal to class. Let's replace F1. F1 is GN1 M2. Okay, F1 ratio F2 is the same as F1 over F2. Please remember, this guy here is the same as this here. Please take notes. So now let's replace F1 and also replace F2. When you do that, we have something like this. F1 is GN1 MS over arrow square 1 over, that is for this, G into, anywhere I see M2, I will replace 10 and 1. Please take note of that, okay? Of N sun over 4 arrow square 1. Please take note. So there's a short way to simplify fractions. If I have something like this, class, if I have 1 over 2 over 3, don't just stress yourself here. Just take this guy here, this 3 here, to this second one here. Please take note. That is 3 times 2. Please take note. But if I have fractions in 3 steps like this, if I have fraction in 3 steps like this, okay, just take this one here, the last one, to the second one. Please take note. Multiply the last one with the second one, okay? But if I have 4 steps of fractions, 4 steps of fractions, like 1 over 4 over 5 over 6, it's very simple. Take the last one here to the first and the third one to the second. So let's apply the shortcut here. So I will have something like this, class. Apply the shortcut here. I will take this last one here to the first, that is here, and take the third one here to the second, that is here. Please take note. Very simple. So when you do that, we have something like this, class. 4 arrow square 1 GN1 M sun over 10 arrow square 1 GN1 M sun. Please take note of this. So class, this guy will cancel this. I'll be left with 4 over 10. So our F1 over F2 will be equal to, class, when you reduce this, 2 go here is 2, 2 go here is 5. So I'll have this to be, class, 2 over 5. Expressing this fraction in ratio is the same as 2 ratio 5. Please take note. What you have to do to get more shortcuts on Jamb topic is to hit the subscribe button, okay?